There are several different types of problems that we'll be solving algebraically where we come up with the equation of a line. And to do this, we'll need two different types of linear equations. The first is slope-intercept, which has the form y equals mx plus b. The other is point slope. And here what we know is the point x1, y1, and we know the slope. Often we'll be using this to get into slope-intercept form, but we don't have to. So let's find the equation of a line that has a slope of 2 and a y-intercept at 4. And this problem is almost too easy because we're given the slope, given the y-intercept is at 0, 4. And if we think about what those things mean, if we look at y equals mx plus b, we know that m is the slope and b is the y-intercept, and we're actually given both of those. So the slope here is 2, the y-intercept is 0, 4. So the answer would just be y equals 2x plus 4. So if you're explicitly given the y-intercept, then that's great. Usually you won't be. So let's look at another one where we're given different information. And in this problem, we're given the slope, and we're given a point that it passes through. There are two ways to do this, and I'm going to show both of them. I'm going to identify what I was told. I was told that the slope was 4 and that the point is 3, 7. Because I'm given the slope and the point, it's helpful to think about point-slope form. So I'm going to identify that this is my x1, y1 pair. In other words, x1 is equal to 3 and y1 is equal to 7. And then I'm going to plug in point-slope form, which is y minus y1 equals slope times x minus x1. Slope is 4, so I can rewrite this as y minus y1 equals 4 times x minus x1. So my x1 was 3 and my y1 was 7. So this can become y minus 7 equal to 4 times x minus 3. Now we could stop there and declare victory, but let's keep going to get to slope-intercept form. To keep going to get to slope-intercept form, I will need to distribute the 4. I'm going to distribute the 4 to the x minus 3. That gives me y minus 7 equals 4x minus 12. Finally, I want to get y by itself. So to cancel out the minus 7, I'll add 7 to both sides. I do that, this zeroes out. Minus 12 plus 7 is minus 5, and I get y equals 4x minus 5 as my final answer. I know this might seem like it's a lot of steps, but once you get into it and you've done it several times, it just kind of becomes automatic that you go from the point-slope form to follow the steps to get to the final answer. It's also possible to solve this problem directly using the slope-intercept form y equals mx plus b. So again, we know that we have a slope of 4 and that our line passes through the point 3, 7. I'm going to start with the equation y equals mx plus b. And the crucial thing to recognize here is that I have a lot of the pieces I would want. I know the m, I know the slope, and I also know an xy pair. Now this relationship y equals mx plus b holds for any xy pair. So what I can do is I can plug in 3 of these pieces, y, m, and x, to find the fourth one. So my m is equal to 4, my x is equal to 3, and my y is equal to 7. And if I plug this information into y equals mx plus b, I get 7 equals 4 times 3 plus b. So 7 is equal to 12 plus b. And if I subtract 12 from both sides, then I get that negative 5 is equal to b. And notice I already had the m. I already had m was equal to 4. So I have the m, I have the b. And this enables me to determine the final answer. The final answer here is just like it was in the point slope calculation, y equals 4x minus 5.